Well, we can classify the elements, break those down into more classes. Metals, nonmetals, and semimetals. Semimetals, like their name says, semi, they're kind of like the metals. They have properties midway between those of metals and nonmetals. Another word for them is the metalloids. Like a humanoid robot is like a human but isn't. Metalloids are like metals, but they're not. Metals are typically solids at room temperature. They generally have high melting points and high densities, and they are usually shiny, right? That fits with our perspective or our thoughts about metals. Metals are good conductors of heat and electricity. That's why we use them for cookware and for making wires, right? Because they conduct electricity. Metals can be hammered into thin sheets. This is a property called malleability. They're malleable. If you hit metal with a hammer, you can cause the metal to flatten out. You can't do that with many other substances. That doesn't work with glass, does it? You know, it's just shattered. And metals are also ductile, meaning they can be drawn into fine wires. And if you're at all interested in that, you should watch, I think it's How Things Are Made. They've got a neat episode on making wire. It's fascinating. Then there are nonmetals. Nonmetals typically have low melting points, low densities, and they're generally not shiny. They're poor conductors of heat and electricity. They're not malleable or ductile, and they generally crush into a powder when you hammer them. 11 of the nonmetals occur naturally in the gas state. Most of the metals are solid. Many of the nonmetals are gases at room temperature. Yeah, okay. And then the semimetals are kind of in between. So the periodic table, we've got a nice big periodic table up there on the wall. Each of the elements has a number that helps us to identify it. That's called the atomic number. So hydrogen's number 1, helium's number 2, and it goes all the way up to uranium at 92, and then there's those other guys that are man-made. They only exist in laboratories. But you're going from left to right in rows, and then coming down, it's all in order. Where am I? Here I am. The metals are on the left side, the nonmetals are on the right side, and the semimetals are in between. So here, if we look at this chart, this table, here, all the metals are shown in purple, and the nonmetals are shown in yellow, and then we've got green in between. Now, many periodic tables, including the one I will give you to use on an exam, have a stair-step line that's dark right through here. Okay? That one on the wall does not, unfortunately. I'd have to get somebody to get up there with some electrical tape and make it. This line is what clues you into where the semimetals are. So the semimetals are the ones that are touching the line, except for aluminum. Can we remember that aluminum is actually a metal? I think we can. We've all touched aluminum. We know what it's like. Things to the right are nonmetals. Things to the left are metals. So you should be able to identify if something is a metal, semimetal, or nonmetal just by its position on the periodic table. If you have a hard time remembering left and right, pick something you know. Oxygen. Is that a metal? No. Oxygen's over here. Then the other guys over there must be nonmetals, and the ones on the other side are metals. This is showing physical states at 25 degrees Celsius, about room temperature. We see that most of the elements are solids at room temperature. Mercury and bromine are the only two that are liquids. Mercury is very odd in that it's a metal that's a liquid at room temperature. And then these nonmetals are all gases at room temperature. And on that periodic table, you can tell the state by the color of the symbol. The red ones are gases, the blue ones are liquids, and the black ones are solids.